All right, so we're going to go ahead and move on into section 4.3, which is all about polynomial division. So we're going to go over long division and also synthetic division and the things that we can find out about our polynomial and about our divisor using those two types of division. Okay, so we're going to start with long division, and we're going to make sure that we remember how to do it by first looking at good old-fashioned long division. Okay, so if I wanted to do 490 divided by 8, that means that 8 is my divisor, right? And then I'm dividing it into 490. So I would write my 8 outside the division house, and I would write 490 underneath my division house. And then I look at how many units I have here, right? I have 1 unit. I just have an 8. So if I have a single digit, that means I start with the first single digit. So does 8 go into 4? No. So I scoot over to the next one. Does 8 go into 49? Yes. It goes in 6 times. So I write my 6 up here, and then I do whatever number I write up here times my divisor, right? 6 times 8 is 48. And then we would say we subtract, right? But I'm actually going to change our verbiage here. Instead of saying subtract, I'm going to say draw my line and change my sign, which is going to make that a negative 48. And then when I combine down, I'm left with 10. And then I start the process again, right? 8 goes into 10 one time, so I write the 1 up above the 0. And then 1 times my 8 is 8. I draw my line, change my sign, and I'm left with a 2. Okay? Whatever we get up here, we call this our quotient, right? Remember these words? And whatever I'm left over with is our remainder. Okay, so there's a cool couple of things that we can determine by doing long division. One, I can determine if 8 is a factor of 490, right? If 8 is a factor, that means it goes in evenly. So notice here we can determine, okay, 8 is not a factor because it didn't go in evenly, right? Because we were left with a remainder. The other thing is if it were to have gone in evenly, I would know that my quotient, whatever that number is also a factor of this original number, right? Here it didn't go in evenly, so we just leave it like this. Or y'all may have written it as 61 little remainder 2 or something like that. Okay, the way that we're going to write it is we're going to write it as our original dividend, or in this case 490, is equal to whatever our original divisor is, so that was our 8, times our quotient, which in this case is a 61, plus our remainder, which is 2. Okay, so this is how we're going to write it as a polynomial. Now, some of them might just ask for the quotient, it might just ask for the remainder, it might ask you to enter the quotient and the remainder, or it will ask you to write it like this. Okay, all right, so let's look at doing the same type of thing with a polynomial. Okay, whatever is out here is our divisor. That's what we call our d of x. Okay, whatever we get for our answer, our quotient, is our q of x, and our remainder, whatever we're left with, we call that our r of x. Right? So notice this is just writing out exactly what we did here. Whatever our original polynomial is, our original number that we're dividing, okay, is equal to what we're dividing it by times the quotient that we got, or how many times it went in, and then our remainder would be 0 if it went in evenly. If it doesn't go in evenly, we write our remainder here. Okay, so let's go ahead and jump into doing one, and then we'll talk about what it means to have a remainder or to not have a remainder in regards to polynomials. Okay, so here it says, use long division to determine whether the given polynomial d of x is a factor of p of x. So in order for it to be a factor, that means it has to go in evenly, right? Then express p of x in this form. So we're going to want to write our answer in this form that we had originally, right? And that should tell us if it is a factor, because if our remainder is 0, then it went in evenly, which means it's a factor. If our remainder is not 0, then it didn't go in evenly, which means it's not a factor. Okay, so let's go ahead and write our divisor, which is x minus 4, and we're dividing that into our original polynomial, which is x cubed minus 2x squared minus 11x plus 12. Notice we have everything from an x squared down to a constant term. It goes from x cubed to x squared to our x term to our constant term. If we're missing any of those, we have to fill in with a 0 placeholder. So I'll show you one like that in a minute. Okay. All right. Now, just like we started up here with our 8, 8 had one single unit or digit. So we started with the first digit. We said, does 8 go into 4? And then if it didn't, we scooted over. We do the same thing here. We look at the number of terms we have. Here we have 2 terms out front. So we're going to scoot over to the second term here, and we're going to write our first number above that term. Okay? And what we're doing is we're asking, what would we have to do to our leading term x to make it look identical to this leading term x cubed? Well, to turn an x into an x cubed, I would have to multiply by an x squared, right? So x squared times x, just like we did here, right? Whatever number we wrote up here, we multiplied it by our divisor and wrote it underneath. So I want to do the same thing here. I'm going to take this x squared, multiply it by both terms of my divisor, and write it underneath. So x squared times x is x cubed. X squared times negative 4 is negative 4x squared. And just like we did up here, we drew our line and we subtracted, right? Well, we're going to say draw our line, change our signs. So when I draw this subtraction line, I'm going to have to change these signs. So this one becomes a negative and this one becomes a positive. Now, if you don't have 2 separate colors of pens to use, I would suggest circling the new sign, and that way you know which symbol to use. Okay, so the first 2 should cancel out because they're perfect opposites. And when we combine down here, negative 2 and now a positive 4 leaves me with a positive 2x squared. And then we bring down our next term, which is negative 11x. Okay, and then we start the process over again. We look at our leading term, which is an x. What do I have to multiply my leading term by to make it look like this leading term? So to go from x to 2x squared, I need a positive 2 and I need another x. So I'm going to write a positive 2x up here. Now I'm going to take that positive 2x and distribute it to both terms of my divisor and write it below. So 2x times x is 2x squared. 2x times negative 4 is negative 8x. And then again, I'm going to draw my line. I'm going to change my sign. So this one becomes negative. This one becomes positive. And then I combine straight down. My first 2 are opposites, so they cancel. My second 2, negative 11x and positive 8, leaves me with a negative 3x. And then I bring down that next term, which is a plus 12. Okay? And then we're going to do it one more time. What do I have to multiply my leading term x by to make it look like this leading term, which is negative 3x? Well, to go from x to negative 3x, I just need a negative 3. So I'm going to take that negative 3, multiply it by both terms. So negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. And then again, I draw my line, change my sign. So this one becomes a positive. This one becomes a negative. And now they actually are both opposites, right? They both cancel out, which means I'm left with a 0 remainder. So first thing I need to know is my divisor a factor of this original polynomial? Meaning, did it go in evenly? And it did, right? So I'm going to go over here and say that what we determined is that x, oops, that is not what we determined. We determined that x minus 4 is a factor of the original polynomial. Okay, so that was the first thing it asked me. And the second thing it asked me is to rewrite my original polynomial as my divisor times my quotient plus my remainder. Now in my math lab, it will literally say p of x is equal to, and it will give you a box, and then it will say times another box plus another box. Okay, because they're wanting you to write this out. They're wanting you to say our divisor times our quotient plus our remainder. And so we would just put in what our divisor was. So here our divisor was x minus 4. Our quotient is the answer we got up here on top, which is an x squared plus 2x minus 3. And then our remainder that we got is a 0. Okay? So if they just ask you for the quotient, you would just enter the answer on top. If they ask you just for the remainder, then you would just enter the 0. They ask you for both of those, you would enter both, or they may have you enter it like this. Okay? All right, so here's some cool things that we know now. We know that whatever this original factor is, the divisor, we know now that it's a factor. The other thing that's cool, and we'll get into this more when we talk about synthetic division, is if I were to solve this, so it's not x minus 4, if I were to set that equal to 0, this would give me x equals a positive 4, right? If this quantity is a factor, then that means its solved form is actually a 0. Or in other words, if I were to take x equals 4 and plug it into this original polynomial, it would equal 0. It gives me a 0 of the polynomial. So every time you find a factor, you're also finding a 0 of the polynomial, which is going to come in really handy with graphing, right? Because every time we factor something, we set each factor equal to 0, and that gives us an x-intercept that then we can graph. So lots of neat things, right? Let's look at another example so we get some practice here. So this one says, excuse me, using the intermediate value determine, oh, that's not the right page. Let's look at this page. All right, so here it's giving us our original polynomial and our divisor. So our divisor, x plus 9, goes outside our division house. And then our original polynomial, p of x, is what goes inside the division house. So we have an x cubed, then we need an x squared, which we have, then an x, which we have, and a constant term, which we have. So we're not missing any terms, so we're good to go ahead and start our long division. I have 2 terms out front, so I'm going to scoot over 2 terms and write my answer above the 6x squared. And I look at what do I need to multiply my leading term x by to make it look like x cubed. Well, I would have to multiply by a positive x squared. So I'm going to take that x squared and multiply it by both terms of my divisor. So x squared times x is x cubed. X squared times 9 is a positive 9x squared. And then I draw my line, change my sign. So the first one becomes negative, second one becomes negative. And when I combine down, my first 2 are opposites and now cancel. And the second 2, 6 minus 9, leaves me with a negative 3x squared. And then I can go ahead and bring down my next term, which is negative 25x, and I start the process over again. What do I have to multiply my leading term x by so that it looks like negative 3x squared? So I would need a negative 3 and another x, right? So negative 3x. So I take that negative 3x and I multiply it by both terms of my divisor and write it below. So negative 3x times x is negative 3x squared. Negative 3x times 9 is negative 27x. And then I draw my line, change my signs. So in this case, they both become positive, right? And then when I combine down, my first 2 will cancel out. When I combine my next terms, I have negative 25 and positive 27, which leaves me with 2x. And then I bring down my next term, which is a positive 18. What do I need to multiply my leading term x by so it looks like this leading term 2x? All I need is a positive 2. So plus 2. 2 times my x out front gives me 2x. 2 times my 9 out front gives me positive 18. And then when I draw my line and change my signs, notice both of these are going to cancel out. So again, I'm getting a 0 remainder. A 0 remainder means I had none left over. It went in evenly. So if it goes in evenly, that tells me that x plus 9 is a factor of the given polynomial. So that's the first thing we had to figure out. The second thing is to write it as my original polynomial, which is p of x, is equal to my original divisor, so my d of x, which is x plus 9, times the quotient that I got, which is my answer up on top, x squared minus 3x plus 2 plus my remainder, which in this case is 0. Now, if on a worksheet or an exam, I ask you to write it out in this form, I'm not going to count off if you don't put the plus 0, because I know plus 0 is the same as just not writing anything there. But the reason I'm writing it here specifically in your notes is because if my math lab asks you to write it like this, they're going to specifically give you 3 boxes. So you will have to enter that 0. Okay. All right. Let's look at one more and then I'll have y'all try some. Okay. So on this next one, again, we're going to go ahead and write our divisor. Let me see if I can focus this a little bit more. Here we go. All right. Focus. We're going to write our divisor, which is x plus 2. And then underneath our division house, we're going to write our original polynomial, which is p of x. So we have an x to the 4th term, which is just x to the 4th. Then we go down to x cubed, which I don't have. So I'm going to write in a 0x cubed. Then I need an x squared term, which here we have negative 2x squared. Then I need an x term, which I don't have. So again, I'm going to use 0x just as a placeholder. And then our constant term, which we have, which is a plus 3. Okay. All right. So now we go ahead and start our division. We have 2 terms out front. So I'm going to scoot over 2 places and write my first one right above here. So what do I have to multiply my x by so that it looks like this leading term of x to the 4th? Well, I would need an x cubed. X cubed times my x out front gives me x to the 4th. X cubed times positive 2 is positive 2x cubed. Then I draw my line, change my sign, so this one becomes negative and this one becomes negative. My leading terms are opposites, so they cancel. And when I do 0 minus 2, I get a negative 2x cubed. Then I bring down my next term and I start the process over again. So my x out front, what do I have to multiply it by to make it look like this leading term, which is negative 2x cubed? Well, I need the negative 2, and then I also need an x squared to bring it up to an x cubed. So negative 2x squared. So I take that negative 2x squared, multiply it by both terms, which is going to give me a negative 2x cubed and a negative 4x squared, right? Make sure whatever number you write up here, you're distributing it to both terms, okay, not just the first one. Once we have it written there, then we draw our line, change our sign, so both of these become positive. The leading terms cancel. My second term's negative 2 plus 4 leaves me with a positive 2x squared and a plus 0x. Then we start again. What do I have to multiply x by to get 2x squared? And we need a positive 2x. So I'm going to take that positive 2x, multiply it by both terms. 2x times x is x squared. Sorry, 2x squared. And 2x times 2 is 4x. And I draw my line, change my signs, they both become negative. My leading terms cancel out. And my second term, 0 minus 4, leaves me with negative 4x. And then I bring down my positive 3. Okay. Last time, what do I have to multiply x by to make it look like negative 4x? I need a negative 4. So negative 4 times x gives me negative 4x. Negative 4 times 2 gives me a negative 8. And then when I draw my line and change my signs, first one becomes positive, second one becomes also positive, not negative. Okay. My leading ones cancel. And my second ones, I have 3 plus 8, which now leaves me with a negative, a positive. I keep wanting to make that negative. A positive 11. Okay. So notice here, because we were left with a remainder, that means this did not go in evenly. So that tells me that my divisor, my x plus 2, is not a factor. Okay. It did not go in evenly, so it is not a factor. But we can still write this original polynomial p of x as my divisor times my quotient plus my remainder. So my divisor is x plus 2 times my quotient, which is x cubed minus 2x squared plus 2x minus 4 plus my remainder, which is 11. Okay, and we leave it like that. All right, so I want y'all to go ahead and pause the video and try the next 2 problems on the next page. And then whenever you're ready, go ahead and play the video again and we'll see how you did. Okay, so on this first practice problem, our divisor is x minus 2. We're dividing it into our original p of x, and we're not missing any terms, so we can go straight into our long division. We should have an x cubed. Make sure after you change your signs, you ended up with a negative 4. Then a negative 4x squared should be your next one. After you change your signs, you should end up with a negative 7. So our next term should be a negative 7x. And then after you distribute and change your signs, you should be left with a positive 10. And that should be our constant term, okay? Which leaves you with no remainder, okay? So I went ahead and identified that we had our quotient and our remainder, and I forgot to write it on here, but obviously because we had a 0 remainder, that means that x minus 2 is a factor of this polynomial, okay? Number 2, same thing, we should have gotten a 0 remainder. Here we did have to put in 2 0 placeholders, our 0x squared and our 0x, okay? Our first term should have been written above our second term of p of x here, which is an x squared. Once we distribute that x squared and change our signs, we should be left with a positive 3. So our next factor up here should be 3x. Once we distribute that 3x and change our signs, we should be left with a positive 9. So our next term should be positive 9. And when we distribute that and change our signs, we should be left with nothing, right? Again, since we have a 0 remainder, that means that x minus 3 is a factor of the polynomial, okay? All right, so that's all on long division. Now we're going to look at synthetic division. Okay, synthetic division is just a more simplified way of doing long division, but without having to deal with all the x's and the changing of the signs and all that stuff. So this is our preferred method. However, please note on your exam, there will be some that specifically say solve using long division. Or divide using long division, or divide using synthetic division. So it's very important when you get those homework problems, you work it in the way in which it's asking you to, because that's indicative of what you're going to see on your exam, and that's how it's going to be graded. So even if you get the correct answer, but you didn't use long division to get that answer, you're not going to receive credit. Okay, so make sure you know how to do the 2 methods. All right. Synthetic division also helps us to see if our divisor is a factor or not. It also helps us to see if we're getting a 0 or not. And so let me just jump in to show you how to do it. So with synthetic, we don't leave it in its factored form. We want it in its solved form. So if I were to solve this, x plus 3 equal to 0 and solve, I would get x is equal to negative 3, right? When I move my 3 across the equal sign there. So negative 3 is what I'm going to use to check it. So instead of seeing if the factor or if the divisor is a factor of this, I'm actually solving it to see if this specific number is a 0 of this polynomial, or if this is an x-intercept of this polynomial. And the way that we do that is we put negative 3 in a little box here, and then we're going to write out all the coefficients. So notice my first coefficient on my x to the 4th is a 2. My next coefficient for x cubed is a 7. My x squared term, I don't have one, so I'm going to use a 0. My x term has a coefficient of 1, and my constant term is negative 12. Okay, so once I have all the coefficients written out, I'm going to leave enough room to write other numbers below these and then just draw a line. Okay, so here's how synthetic works. We bring down our first number, which is a 2, and then we multiply that number by the number in our box. So 2 times the negative 3 in my box gives me a negative 6, and I combine down exactly how it looks. 7 minus 6 is 1. 1 times the negative 3 in my box is negative 3. And then I combine down. 0 minus 3 is negative 3. Negative 3 times the negative 3 in my box is positive 9. And when I combine down, 1 and 9 gives me 10. and 10 times the negative 3 in my box is negative 30. Okay, and when I combine down, I get negative 42. So that's the entire division process. So now let me tell you what these mean. Okay, so this last number that we got here at the very end, this is our remainder. The next term over is our constant term, then our x term, then our x squared, and then our x cubed. So what this is telling us is when we take this big original polynomial and divide it by x plus 3, this is our quotient. Okay, what's down here is our, whoops, I spelled it wrong, quotient. Okay, so if it asks us to identify our quotient and our remainder, for our quotient, we would write 2x cubed plus 1x squared, or we don't have to write the 1, we could just write x squared, minus 3x plus 4, and our remainder is negative 42. Okay? So a little bit easier than synthetic division. And because this did not give us a 0 remainder, that tells me that x plus 3 is not a factor. And I know it didn't ask us to find that, but I just want y'all to make that connection. Okay, it did not go in evenly, so it is not a factor. The other super cool thing that division tells us, whether we do long division or synthetic division, is the number that we get as our remainder is actually the number or the value that we would get if we took that specific 0, which in this case is negative 3, that's what's in our box. If we took negative 3 and plugged it into this polynomial, it would equal negative 42. So now we have a new way of evaluating functions. Okay, if I claim that this is p of x, what we also found out is that p evaluated at negative 3, right? If we were to plug that number in, it would equal our remainder, which is negative 42. Okay, so now when we start plugging things in, like on those graphing problems we did where we had to find the end behavior and all the zeros and if it touches or crosses, and then we had to plug in test points. So those test points, now we could actually use this process to plug them into the original polynomial to see what the y value is. So new tool in our tool belt. Okay, all right, let's look at another one. Same idea here. I want to make sure that my factor is solved. So if I set x minus 1 equal to 0, that means I'm looking at x equals 1. So I want to know, is 1 a 0 of this polynomial? Okay, or in other words, does it give me a 0 remainder? So my x to the 4th coefficient is a 1. My x cubed coefficient is a 0. My x squared coefficient is a 0. My x coefficient is a 0. And my constant term is a negative 1. Okay. So make sure if you're missing any terms, we fill in with 0 placeholders. We bring our first number down. 1 times the 1 in our box is 1. We combine down and get 1. 1 times the 1 in our box is 1. We combine down and get 1. 1 times the 1 in our box is 1. We combine down and get 1. This is all very exciting. 1 times the 1 in our box is 1. We combine down and get 0. So notice our remainder is a 0. That means that this number is an actual 0 of this function, right? Which means that x minus 1 is a factor. So let's go ahead and write what our quotient and our remainder are, and then we'll write that stuff out. So our remainder is 0, our constant term is x, our x is 1, our x squared is 1, and our x cubed is a 1. So that means that our quotient here is x cubed plus x squared plus x plus 1, and our remainder is 0. So that's what it actually asked us to find, but what we found, because we know that the remainder is a 0, we can actually say that x minus 1, our original divisor here, is a factor. Okay, we determine that. And if x minus 1 is a factor, that means its solved version, 1, right, the number we put in our little box, x equals 1 is a 0. Okay? Or in other words, if I were to plug p of 1 into my function, I would get 0, assuming that this is my original p of x polynomial. Okay? All right, so that is basically what all this stuff is explaining. It's saying that if our remainder is 0, we know that our divisor is a factor, and that the value we used in the little box is a 0. Okay? If our remainder is not 0, then we know that our factor or our original divisor is not a factor. And we know that if we were to plug that number in our box into our function, it would equal whatever we got for our remainder. Okay? Okay, so I want to show you the same example, but use it in such a way that we're validating whether or not given values are zeros. Okay, so instead of us being given a division and determining quotient remainder, we're now actually being given values, and we're going to use synthetic division to determine if they're zeros. Now, in order for it to be a 0, okay, if the numbers are zeros, that means that the remainder equals 0. Okay, so if our remainder equals 0, then the given number is a 0 of the polynomial function. If it's not a 0, well, then at least we know what it equals when it's plugged into the function. Okay, so let's look at -3. So if I put -3 in my box, I write out all my coefficients here, and notice I'm not missing any. I go from x cubed to x squared to x to my constant term. So I can just write out 3, 5, -6, and 18. I do my synthetic by bringing my first number down. 3 times the -3 in my box is -9. 5 and -9 gives me -4. -4 times the -3 in my box is +12, which combines down to +6. +6 times the -3 in my box is -18, which gives me a 0, right? So if I get a 0 remainder, that means that the value that I just checked in my box is a 0. So this means that x equals -3 is a 0. Okay. Now let's check 2, because they wanted us to check 2 also. So we put 2 in our box, write out all our coefficients, which are 3, 5, -6, and 18. We bring down our first number, which is a 3. 3 times the 2 in my box gives me a 6, which combines to 11. 11 times the 2 in my box is 22, which combines down to a +16. 16 times the 2 in my box is 32. And 32 and 18 gives me 50. Remember, this is my remainder, and here it's not 0. So because it's not 0, this tells me that the number in my box is not a 0 of this function. So x equals 2 is not a 0. Okay. Good. All right, I want to show you one more example, doing the same thing, except this time's checking whether to see complex values are zeros, right? Because sometimes when we set a function equal to 0, it is possible to get complex solutions. So we can actually check those complex solutions the same way we do our regular real number solutions. So we're going to start with I. We're going to put I in our box. Now, when we're dealing with I's, our numbers can get a little funky, a little long looking. So when you write out your coefficients, leave a little bit more space than you normally would. So my x cubed is a 1, my x squared is a -4, and then I have a 4, and then I have a -16. I'm going to spread it out just a little bit more. Okay, so I bring down my 1. 1 times the I in my box is I. Now, when I go to combine down, I can't actually combine these into one term because one's an I term and one's a real number term. So I'm just going to write them side by side. I'm just going to write this as -4 plus I. Okay, so now -4 plus I is what I need to multiply by the number in my box. And I'm going to come do it down here below just so that I can kind of think through it. So if I do I times -4 plus I, right? If I just do the number in my box times what's down here, I'm trying to figure out what I can write here. So I would distribute this and get -4I plus I squared. right? And then remember, I squared is equal to -1. So really, this is -4i plus a -1. Or in other words, just 4i minus 1, right? So I'm going to write that up here. So I have -4i minus 1. Now, when I go to combine down, I can't do anything with this -4i because I don't have an I term up here to combine it with. So I'm still going to have -4i, but I can combine the 4 and the -1 to get a +3. Okay? So now I'm going to take this -4i plus 3 and multiply it by the I in my box so that I know what I can write here. But I'm going to do that down below. So again, I times -4i plus 3. I distribute my I, which gives me -4i squared plus 3i. And then remember, I squared is -1. So if I do -4 times -1, that's going to make this a +4 plus 3i. Okay? So that's what I'm going to write up here below my -16. So 4 plus 3i. Okay? And again, when I combine down, I can combine my -16 and my 4 to get -12 plus 3i. And then obviously this is not a 0. So if it's not a 0, this tells me that x equal to whatever's in my box here, which is an I, is not a 0 of this polynomial function. Okay? So it would have to equal 0 or go in evenly in order for I to be a 0. So let's try another one. Let's check -2i. So we're going to put -2i in our box and write out our coefficients, which are 1, -4, 4, and -16. I bring down my 1. 1 times the -2i in my box is -2i. And again here, I can't combine these because one's an I term and one's not. So I'm just going to write this as -4 minus 2i. And then I'm going to multiply that by the -2i in my box. And I'm going to do it down here. So the -2i in my box times -4 minus 2i. And I distribute. -2i times -4 is a +8i. -2i times -2i is +4i squared. And remember, I squared is -1. So I end up with 8i minus 4. So that's what I'm going to write under this next number. 8i minus 4. Notice I can't do anything with this 8i, but my +4 and my -4 are opposites, so those just cancel out. So I'm left with just 8i. So now I'm going to do 8i times the -2i in my box. And again, I'm just going to write it below here. -2i times 8i. -2i times 8i is -16i squared. And then remember, I squared is -1. So -16 times -1 makes this a +16. So that's what I'm going to write underneath my next number. And they happen to be opposite. So that gives me a 0 for my remainder. So because I got a 0 remainder, that means whatever's in my box up here, which is -2i, is a 0. Okay. Okay. So I want y'all to try the same process. Okay. Just take the numbers that are given to you, plug them in using synthetic. If you get a 0 remainder, then that means the number in your box is a 0. If you don't get a 0 remainder, that means the number in your box is not a 0. Okay, so on the next page, there's a practice problem for you to do that with 3 different values, -2i and -i. So go ahead and pause the video and try out those 3 values and then unpause it and we'll go over them. Okay, let's see how you did. You should have gotten a 0 remainder on every single one of them. Okay, so if you did not get a 0 remainder on every single one of them, make sure you look through and see where you might have made a mistake. -2, excuse me, most of the time nobody has a problem with this. We bring down our 1. 1 times -2 is -2, which combines to 0. 0 times -2 is 0, combines down to 1. 1 times -2 is -2, so we're left with nothing. Okay, that means the number in our box -2 is a 0. Same thing on I, a little bit more work, same process. We bring down our 1. 1 times I gives us I. We combine down, we can't write that as one term. We have to write it as 2 plus I because those are not like terms. So we're going to do 2 plus I times the I in our box. Once we do that and simplify, we should get 2I minus 1. Okay, so we put our 2I minus 1 up here. Excuse me, my 1's cancel and I'm left with just 2I. And then 2I times the I in our box, you can see the work down here, should simplify to -2. And then 2 and -2 combine to 0. Okay, and then we do the same thing with -1. -1, we bring down our 1. 1 times -I is -I. Again, we can't combine them, so we just write them side by side, 2 minus I. So we do 2 minus I times the -I in our box. Here's the work for that. Oh my goodness. So it ends up being -2I minus 1. And up here, again, our I, or sorry, not our I's, our 1's will cancel. We're left with -2I. Oh, excuse me. -2I times the I in our box simplifies down to just -2. We put our -2 up here. It combines to 0. Okay. All right. So that is the end of section 4.3. So you should now be able to complete that assignment on my math lab. If you have any questions, please let me know.